Hello, my name is Minjung. My name is Soyeon. Today we'll talk about what we learned in last class. Last class we learned about MOSFET. MOSFET is field effect transistor which is constructed by metal oxide and semiconductor. And field effect transistor is the device that the current between the two terminals and that current is controlled by input voltage. And this is the picture of NMOS M-channel MOSFET. The middle side is gate and left side is source and opposite side is drain. And downside is body is equal to substrate, and at the NMOS the substrate is doped by p-type and the source and drain is heavily doped by n-type. And there is three kinds of state of current between source and drain. First one is cutoff, when the body voltage is 0 or ground and the gate source voltage is much smaller than threshold voltage, then there is no channel between source and drain, so the current cannot flow between the two terminals. And next, the second one is linear state, is same as triode state. When the VGS is much bigger or same with VTH, then the channel is formed between the drain and source. So it is because of the vertical E field, and the channel is equal to inversion layer because the substrate is p-type, but the channel's carrier is electron, and drain source voltage is smaller than VGS minus VTH. Then the current flows from drain to source, and electron flows from source to drain. And last one is saturation state, when the gate source voltage is bigger than threshold voltage and the drain source voltage is bigger or same with VGS minus VTH, then the channel near the drain is going to be small, and that point is pinch off. And after that point, the depletion part is going to be bigger and bigger, and then the channel length is going to be smaller. We see before that there are three states in MOSFET's activation. So we can see that drain currents and drain source voltage by characteristic curve. So I put drain source voltage in x-axis and drain current in y-axis. First one is cutoff state. Cutoff state is that there is no channel between source and drain, so drain currents cannot flow. So that drain currents get 0. And second, this is linear state. Linear state, we can see in this characteristic curve, linear state's part is left red line. So when you see this equation, there are two variables. First one is gate source voltage, and second one is drain source voltage. When gate source voltage is increased, then drain current will go up, and also drain source voltage is increased, then drain current will be increased too. So in this equation, gate source voltage and drain source voltage is important variables. And third part is saturation states. And when you see this graph, that right side of red line is saturation state. When you see this equation, there are only one variable, that is gate source voltage. This is different from linear state. Linear state has drain source voltage in variable, but there is no drain source voltage. So in these parts, when drain source voltage is increased and there are no change in graph. But when gate source voltage is go up, then drain current will be increased. And this is channel length modulation. Channel length modulation appeared in saturation states when VDS and VGS minus V threshold voltage is equal. Then there are pinch-off states, and when drain voltage is increased, that there are more depletion region, and channel's length will go small. So that drain current will go up together because depletion region is increased and channel's length is go small, so there are more current will flow. So you can see this graph that drain current will go up.